Hi everyone and welcome back. So today we're going to be talking about the midpoint formula. So midpoint should sound self-explanatory. It's going to be the point, so that's going to be the point in the middle of 2 points. It's going to be evenly spaced, so right in the middle. All right, so if I were to draw an example here, so if I were to be looking at, let's say this was a value 10 and this had the value of 30, the value that would be midway or the midpoint between those two, so you want to be going right in the middle, would be 20. So that would be evenly spaced, a distance here of 10 and then a distance here of 10. So the formula we're actually going to be using to talk about midpoint, finding the point midway between 2 points, is the following. So we will have for the midpoint, our midpoint formula is going to be x1 plus x2 all over 2, comma, y1 plus y2 over 2. Essentially, all we're doing is we're just summing the x values and averaging them. We're summing the y values and averaging them. So if I gave you the point 1, 5, and the point 4, 2, so let's draw that in here, 4, 2. And we want to find the point that is going to be midway in between. So we got to find those coordinates. And the way that we can do that algebraically is by adding these x values. So we'll have 1 plus 4 all over 2. And we'll have 5 plus 2 all over 2. So to find that midpoint of these values, we're just going to sum. 4 plus 1 is 5, so I'd be at 5 halves, comma, 7 halves. And really, if you were to write that out as a decimal, you're looking at 2.5, 3.5. So I'm at the point 2.5 here, and then up 1, 2, 3.5. So I'm actually right here, right in the middle of those points. There's your midpoint. All right? All right, so let's take a look at doing some of these examples together. So let's look at the first one. All right, so again, I'm just going to write out my formula, but now the question wants this to be done graphically. I'm just looking to have the formula handy because this is something you are going to want to memorize. Not too difficult, though. So we have the midpoint formula. We have x1 plus x2 all over 2, comma y1 plus y2 all over 2. We average them. But now graphically, let's just start by graphing these points. So let's graph 2, -4 and -6, 2. Now, if I were to connect these points with a nice straight line, one way that we can do this is also, too, we can count the slope. Let's see what the slope is. So I'm rising up to, so let me indicate that here, rising up to, and then to the right, I'm going by 1, 2, 3, 4. So we have 2, 4. So the slope here is 2 over 4. Now, if I simplify that, the slope here was really 1/2. So I can write, let's see what happens. So that means there's going to be a point at 1 over 2 when I go on my slope. So I'm going to rise up 1 and over 2. Now, if you look, the slope from here to here is exactly up 1 over 2, and then here to here, again, it's exactly up 1 over 2. So there is my midpoint. That point is exactly in the middle. So that value we found graphically is at 1, 2, 3, 4, -1, 2, 3. So we're at the point 4, -3. So there is your midpoint. That's by just doing it graphically. Just find the value that's exactly in the middle. Okay, let's look at a few more questions. Okay, so again, we're going to be finding the midpoint between these 2 points graphically. And then we'll continue into finding some of them algebraically. But again, let's just start by graphing them. So I'm going to graph my points at 3, 8, and then -5, 6. All right, so I just drew my points, and now I connected them with a nice straight line because I want to find the point that's exactly halfway between those two. So again, I'm going to take a look at the slope as I go from one point to the other. Now, it doesn't matter if I start here or start here. I'm just going to start at this point, -5, 6, and count. I'm going up 2 boxes, and then I'm running to the right by, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So my slope here, we have 2 over 8, which I can simplify to 1/4. So let's see what that's going to look like. So I'm going up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. And if you guys look, this has a slope from here to here of 1 over 4, and this has a slope from here to here as 1 over 4. So halfway in between, we're at that point, -1. And let's see, 1, 2, 3, 4, 5, 6, 7. Guys, another way that you can look at this, so if you see I have the points 3, 8, and I have negative 5, 6, this is just another way to look at it. If I look at the x values at negative 5 and 3, what's halfway between negative 5 and 3? Well, halfway between is the point negative 1, that x value of negative 1. This has a distance of 4 and 4. So that kind of already establishes halfway in between. I know my x value is negative 1. Now if I take a look at these y values, and I'm going to create a number line as well here for 6 and 8. And we can tell just from looking at this, halfway between 6 and 8 is that number 7. So that tells me that my y value will be at 7. This is really just another way visually, if maybe this makes a little bit more sense to you, what I just did right here, you can use this as well, whatever works for you. Okay, again, let's take a look at now question 3, finding the midpoint now graphically. Again, you can do this multiple ways, guys. You've got graphically, algebraically, you have this number line method I just showed you, however your brain thinks and is easier for you to implement this. So again, I'm going to graph these points, 7, 9, and negative 3, 6. All right, so I drew in my points here at 7, 9 and negative 3, 6. And now again, we want to find the midpoint between these 2 points. So I wrote over here our rise and run. So I rise by 3, and then I'm running by 10. So my slope is 3 over 10. And now this is actually going to be a little difficult to do graphically because as you can see, the number is it's not going to work out very nicely. So let's take a look at how to do this then algebraically. So I'm going to write down my formula. We have the midpoint is equal to x1 plus x2 all over 2, comma y1 plus y2 all over 2. Now, I have my x1 and x2. So there's my x1 and x2. So I'm going to add those. So my midpoint, I'll call it m, will be 7 plus negative 3 all over 2. And now my y values, I've got 9 and 6. So there's my y1 and there's my y2. I have 9 plus 6 all over 2. And just a little bit of algebra here. We'll get our midpoint to be, I have 4 over 2. And what else do we got? 15 over 2. And if I simplify this, my midpoint will be at 2, comma, 15 over 2 is 7.5. So see, the number it's not as nice as we're used to. It's not a whole number, but that's okay. So really, I'm just looking at my point at 2 and then 7.5. So that's about here. There would be my midpoint. Awesome. Alrighty, let's take a look at just 2 more examples and you guys will be good to go to get some practice in there. So for question 4, we're finding actually 4 and 5 are going to be done algebraically. So that's kind of nice. We got algebraically for both of these, but you can still graph them as well if you would like. I personally am not going to graph these because if you look at these numbers, they're kind of huge. I've got negative 115 and 1711, 22 negative 9, and negative 13 0. So I'm actually going to skip the graphing for this piece just because I want to go the algebraic route because that's also good practice for us. I'm going to show you guys doing it by plugging into the formula and then also that number line method if you prefer that better. So let's start with the number line. So we have negative 115. I have 1711, and we're trying to figure out the point that's in between. So if I make my number line, so let's do that here. If I make a number line using these points, I'm going to focus on the x values first. I have a point at negative 1, and then I have a point at 17. So the point that's going to be halfway between, I want to know what's halfway between negative 1 and 17. Well, what's that distance? So halfway would be a total distance of 9 in between each point. So if I did 17 minus 9, that gets me 8. So 8 is equally between negative 1 and 17. That's the halfway mark. So I know my x value here will be 8. Now if I take a look at my y values, so let's do that in a different color here. Let's go with black. So if I take a look halfway between 15 and 11, so let's do that here. Draw my little number line. Here's 11. Here's 15. And I want to know what's halfway in between. Well, from 11 to 15, that's a total distance of 4. So if you cut that in half, you'll have 2 and 2. And 11 plus 2 is 13. So halfway between is 13. So there you guys have it. Just by looking at a number line, I was able to figure out the midpoint is 813. But now let's actually do this with plugging into the formula. Again, this is all about if you're a visual learner, if this is easier for you to look at, definitely take this approach. But otherwise, let's take a look at how to do this by plugging it into the formula. All right, remember our formula, x1 plus x2 all over 2, and y1 plus y2 over 2. Guys, the order doesn't matter here. Remember the commutative and associative properties here. This is addition in the middle, so that's not going to affect the order at all. So it doesn't matter if you end up switching it, but let's try to keep it consistent, as that's actually very important for us when we apply the distance formula, which will be coming up in our next lesson. So x1 is my -1, so I'll have -1 plus, my x2 is 17, all over 2. I have 15 plus 11, all over 2. And let's see, -1 plus 17 is 16. 16 over 2 is 8. And 15 plus 11 is 26. 26 divided by 2 is 13. So as you guys can see, by using the midpoint formula or plugging it in on a number line and checking out that midway point, you still get the exact same solution. All right. Why don't you give question 5 a try? I will post both of my solutions here using both a number line and then plugging into the midpoint formula. So first, we should probably start off with the midpoint formula. And again, reminding you, it's just, so I'm going to write m for midpoint, x1 plus x2 all over 2, y1 plus y2 all over 2, and we're just plugging in. So why don't you guys give this a try? I'll also post my solutions with my number lines as well. Alrighty, and there you guys have it. Here's my solution. Again, I did the midpoint formula first, so I just plugged in for my x1, x2, y1, and y2. You end up getting the midpoint is at 4.5, -4.5, or you can leave it as the fraction as 9 over 2 and -9 over 2. If you forgot how that turned into a fraction, remember you guys can just click that math frac button to turn it into a fraction. Our x values, again, I did it on the number line. So on the number line, I wrote down my x values of 22 and -13. So those are here. And I found that the distance between those two was 35. But I want to be halfway in between, so I just cut that number in half. So that's a distance of 17.5 between each point, which if I either do 22 minus 17.5 or -13 plus the 17.5, I'll get to my midpoint of 4.5. And then again, I also did that for the y values. So my y values are -9 and 0. So I have my -9 and 0 here. That has a total distance of 9 between them. So if I cut that distance in half, I'm at 4.5 on either side. And if I just travel backwards between 0 and -9, so if I travel backwards from 0, that brings me to -4.5, which is how I got my midpoint. So they're both the same solution. Either of these is going to work. Again, midpoint formula is probably your best bet, but for those of you that maybe like to see a visual representation of this as to how you're getting midway, there you have it. All right, guys, I hope you found this video helpful on midpoint formula. Stay tuned for distance formula coming up.